It's the bonus video. Da, 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 da. It's on configuring router-based DHCP services. Now you might be thinking, why is this a bonus video? I'm not sure. It's one of those topics that I wouldn't have placed in the bsci world with routing protocols, with IP version 6. I mean, all of these routing based topics, and all of a sudden, poof, DHCP services. Why is it here? Well, because it's on the BSCI certification exam. No other reason. I was just doing one last check to make sure we hit all the major objectives as we went through this video series. And then I saw DHCP services and I thought, oh yeah, this belongs in a CCNA course. It's one of those kind of foundational concepts, but I think it just slipped through the cracks and Cisco at some point in the program said, let's just throw it in BSCI. So here we are. We're going to take a look at how iOS-based DHCP services are configured, because you can configure any iOS device, be it a switch or a router, as long as it has layer 3 capabilities, to be a DHCP server. We'll look at importing and reusing DHCP options. That'll make more sense when we look at it in the configuration. And by the way, that's where we're going to thrive in this video, is all in the configuration interface. And then, of course, the biggest command of them all, an IP helper address. If you have ever configured a Cisco campus environment before, you will not see, or I should say rarely see, a campus environment that does not have this command in use somewhere. We'll look at what it is and why we would use it. Well, let's not waste any time and get right into the configuration. iOS-based DHCP services have some advantages, being that they are running on one of the stablest platforms that you possess in your enterprise. Most people run DHCP services on Windows 2000 or 2003 or whatever brand of Windows you're using, because in that world, you have the GUI. You can point and click and configure things through a wizard, which most Microsoft admins do. And usually, in the divide of authority, Microsoft people have authority over their little DHCP clients. Now, the advantage, as I was saying, of configuring an iOS-based device for DHCP services is that it's stable. If your Windows server crashes or gets a new patch or updates itself and reboots, the DHCP server doesn't go offline. iOS devices, stay up for years many times. So that's your advantage. The disadvantage is that it's not pretty, meaning you're typing it in, you've got a text-based command line configuration, which you and I love, but Microsoft people don't love. The main thing that you lose when you go with iOS-based DHCP services is the quick and easy view of what clients have what IP addresses, which I will be the first to admit is very handy. I like going in Windows, clicking on that address leases option, and it just shows everybody who has it. There's a way of doing it in a Cisco router, but that means you've got to telnet to a Cisco router, which for the Microsoft admin, you usually don't want them telnetting to your Cisco router. So let's walk through the configuration of a DHCP server on an iOS device, and then I'll show you some of those options to view what addresses have been used. First thing that you want to do, it seems a little backwards, but the first thing you want to do is exclude the addresses that you don't want from being used. So for instance, I'll do a show IP interface brief. Router 4 just has an Ethernet 0/0 interface. It's currently running IP address 10.1.1.1. So maybe I want to assign the addresses 10.1.1.20 through 10.1.1.254 because that's the pool that I want to use. Well, before I create the pool, I need to exclude the addresses that I don't want to use, because once I get into the pool configuration mode, there is no exclude option. Here's how you do it. It's a global config option. I type in IP DHCP excluded address, then I put in my start address or low IP address. I'll put 10.1.1.1, and my end IP address or high IP address. To do individual reservations, I can just hit carriage return. I don't have to put a high one, and it will just not assign 10.1.1.1. But I said I don't want to use all the way up through 20, or wait a sec, I said 10.1.1.20 was where I wanted to assign. So I'll reserve or exclude 1 through 19. So now that I've excluded my addresses, I can type in the command ipdhcp pool and then a name. So you can give it a nice logical name. Maybe this is the marketing subnet. It is case sensitive, by the way, so if you ever reconfigure it, you'll want to remember that you used capitals. So I'm under the DHCP pool options, and the first thing I get to define is what network I want to hand out from. You type in network, 10.1.1. And then 0. That's the entire network range. And look at this. It's awesome. I wish they would add this to the IP address command. You can use bit notation or the decimal subnet mask for your prefix there. So I could go ahead and put a /24 if I want to hand out Class C range. So at this point, the router is handing out IP addresses. So it is ready to go. It's sending them out, and if I have clients asking for them, they're being deployed. But I haven't configured enough options yet. For example, a lot of people want a domain name with the address so that the clients will be assigned to the correct DNS suffix. So I could put domain name cbtnuggets.com. And at that point, everybody that receives an IP address will get that DNS suffix added to their IP configuration. They might want DNS server configurations, and I could put DNS server is 10.1.1. Maybe 10, and you can hit a question mark and type in multiple ones. 10.1.1.11. So I've got a primary and a secondary DNS server that's assigned. Let's see what other options we've got. Oh, if you're using Wins, the good old Microsoft on its way out name resolution type, you can type in NetBIOS name server and type in the address of that. Maybe it's the same as your DNS server. So at that point, you're handing out a Win server. But you can, I mean, you can look at those options right there, and you have the ability to do just about anything that you could in the Windows world, or I should say everything that you could. Oh, one of the biggest ones you want to hand out is that guy. Default router. That's the default gateway address that you're going to hand out to your clients, and we'll point them to me on router 4. I am their default gateway. So at that point, I've assigned all major options. Now, one of the good things, and I don't know if you know this, but every option, I said option, has an option number. For example, and I'm going to pull these off the top of my head, so forgive me if I'm off. I think DNS server is option number 6. I think default router is option number 3. I'm just pulling those off the top of my head. There's actually a big list of DHCP options out there that you can configure. Some of them are proprietary, or some of them are for unique purposes. For example, I get into the voice over IP world a lot, and a lot of people will use something known as option 150 to point the IP phones, voice over IP devices, to a TFTP server to get their configuration, to get music on hold, sound files, and all that. So we actually go in there, and you can see the option command. I type in option and what option I want, 150, and give, the IP address or hexadecimal value or ASCII name, whatever I want to assign to that option. So if there is something that you want to hand out via DHCP, this lists all the common options up here, like domain name, DNS server, that sort of stuff. But you can very well just type in the option number of all valid DHCP options. You only have 0 through 254, and manually hard code your proprietary options in there. So that's the idea of configuring a DHCP server on a Cisco router. Now at this point, I want to also show you how to set up a router as a DHCP client. I don't have a topology because this is such a simple topic, but if I jump back here and go to router 3, I'll do a show IP interface brief, you can see that router 3 has an Ethernet interface and it currently has an IP address that is unassigned. So you can set up a router to receive a DHCP address just by going under an interface and typing in IP address DHCP. Now you might wonder, where on earth would I use that? I mean, come on, it's a router. Well, think about it. We have all kinds of Cisco routers. I have a Cisco router at home. Yes, I am one of those people. And I have a DSL connection, and they only allow me to receive addresses via DHCP. If Cisco routers couldn't do it, then I couldn't use it to route my DSL connection. Same thing with cable modems. A lot of the common cheap internet service provider connections all do addresses via DHCP. And you can see, look at this. As soon as oh no, bummer. I was gonna say as soon as I did this, it grabbed an address, but it grabbed it from the wrong DHCP server. Hang on, I actually have. I forgot that I had a DHCP server running on this subnet that complements the DHCP server we just configured on router 4. It just happened to get one from the wrong pool. You can see that it works. The command works. Let me do something. I'm going to stop the recording real quick and go shut down my other DHCP server so that router 3 can grab an IP address from the pool we just configured on router 4. And that way we'll be able to verify that it's been configured correctly. All right, I'm back. Now you can see all I did right here was I went and shut down my DHCP server. It's actually on a 3550 switch that I have for all the VLANs that I have in my house. Yes, I have VLANs in my house. I have one for every room, and I even have a VLAN for the garage because I have things in the garage. You can now mock me at your will. But I went in, I shut down the DHCP server, went back under Ethernet 0/0, did no IP address, and then I did IP address DHCP again. And now you can see it was assigned an address from the DHCP pool that we set up, 10.1.1.20, because that was the right IP address. This highlighting thing just isn't working for me. Here we go, 10.1.1.20. That was the pool that we created and set up on router 4. So now that this has the IP address, let's do a show IP route. I want you to also see that the Cisco router honors DHCP options pointing to a default gateway. If it doesn't already have a static route, static route 0000, it will accept an option for a default gateway from DHCP, which also is very handy when you have that DSL and cable modem connection. So I'll do a show IP interface brief. There's our IP address. We know it's now assigned. Let's hop back over to router 4, and I'm going to type in a command, show IP DHCP binding. Hit enter, and you can see right here that 10.1.1.20 has been acquired. It's been used by the router, and you can also verify its MAC address. Wow, look at that. I've got to admit, guys, I have never seen this this sort of MAC address. Hang on, that is weird. Usually you just see a straight up MAC address coming across right there. That's a, well, actually, even that's a, what on earth is that? Let's go over to router 3. I'm going to do a show interface, Ethernet 0/0. All right, that's its MAC address. Do you see that anywhere in that output? 0003. Wow. Well, that is interesting. And that's about all I'll say on that. Usually, I'm not too sure why it's giving me that wild MAC address right there, but usually, no, yeah, I'm not going to go any deeper. I'm sure it's something just weird going on. But usually it will just be the MAC address of the client that received the IP address. But now this does, to verify these bindings, this does require that you're on the router typing in show IP DHCP binding. So Cisco introduced a pretty cool command. I like it. You go into global config mode and you type in IP DHCP database. But you spell DHCP right. DHCP database, and you can specify a URL where a database is contained. Now you might be thinking, what do you mean? Like, are you talking SQL database or something here? Not at all. What I mean is that you just have a TFTP server or an FTP server set up that you could type in like TFTP : / maybe 10.1.1.50 is the TFTP server / and we'll just put DHCP bindings.txt. That will automatically send all of this to a TFTP or an FTP server, if you want to use an FTP server, and stored in a file that's dynamically updated called DHCP bindings. Whew, so good news. You don't want the Microsoft administrator on your Cisco router to check bindings. You don't have to. You can just export that to a file. And the cool thing is it puts it in the comma delimited format, so you can import that into Excel. You can put it into a SQL database. You can do whatever you want. So that's the good news of that. You also have the option on here to do a write delay. which will specify how long it waits to write to the TFTP server, or waits to write to the quote unquote database file after assigning addresses. Because, I mean, think about it. If you have 8 in the morning, everybody boots up their PC, you don't want the router just hammered doing all these writes to a TFTP server. So you can say, do a write delay of 180 seconds. So after 3 minutes of sending out addresses, it will update the database on the TFTP server. So that is how you set up a iOS-based DHCP server. Now let's expand on that a little bit, because I also mentioned importing options. What this import options is this environment. Let's imagine that you had a Cisco router routing for a small office. And since it is a small office, it just has a simple DSL internet connection. I actually work with offices like this all the time. It's uh, very easy to set up a router configuration to route this sort of thing. And inside, maybe they've got 10, 20, 30 PCs, just a Soho style environment. Now, the DSL provider is sending you IP addresses and stuff like that, via DHCP to your interface. And also in there, they're going to have their public DNS servers and so on that they have configured and dynamically sent to you via DHCP. Now, this is a small enough office that they don't have their own Win server and DNS server. They just want whatever the service provider gives you via DHCP to be assigned to these guys. Well, how do you do that? Well, you could either receive the IP address and then do some show commands to see what the servers are and then manually assign them to the clients using DHCP or manually typing them in. But what if the provider changes their DNS servers or something like that? Well, then we got to go manually change it all. That's why we have this option known as importing. This is what, if you remember the objectives, I talked about auto configuration or the import all. That's what this is you can actually import the settings from the outside DHCP address and then send them via DHCP to all your clients. I kind of think of it this way. My wife and I just had our first baby not too long ago, and we just got a ton of baby gifts because it's like the first baby in my family in 40 years. It's wild. It's really exciting. But we got all these gifts that, I mean, some of them are just weird because, sometimes people just get you weird gifts. And so you think, I don't really want this, but maybe somebody else is. So we do this thing we've kind of patented called regifting. I know it sounds kind of scandalous, but when we get a gift from somebody that we don't really want, we kind of regift it to send it to other people that may want it more than us, which sometimes includes donations. So that's what this is. It's like regifting all of those outside statistics to your internal clients. It's easy to do. It's one command. You just go under the DHCP pool that you want to send that information to. Oh, and it's giving me a bunch of errors saying there is no TFTP server right here. I know, I just made that up. So I'm going to go IP DHCP pool, and what did I call it? Marketing. What did I call it? Right there, marketing subnet. So paste that down there. So I'm back under there. One command, you just type in import all, enter. At that point, you are ready to send anything that you receive via DHCP on the outside to the devices on the inside. Now you can see it's trying to import, but it's going to say, wait a sec, I'm not getting an IP address from the outside. So the command will end up failing, but that is what the import options do, allow you to regift those options to your clients. The last thing that we'll talk about is the infamous IP helper address. The IP helper address is awesome in environments when you have centralized DHCP services, and that happens a lot. That's in a lot of corporations. Let me give you an example. Let's say we've got a maybe a multi-layer switch like a 6500, connecting to IDF closets with wiring and many different clients attached. And we've got VLAN 100, which is maybe our servers, VLAN 200, which is our marketing folks, VLAN 300 which is another group of random people. All these different people have different subnets because a VLAN is a subnet. And this multi-layer switch eventually connects to the router, which connects to the WAN, which, maybe has a branch office over here that has maybe 10 employees that are just working and doing their thing and so on. Well, the problem of doing VLANs and all these different subnets is that if we didn't have this helper address concept, we would have to have a DHCP server assigned for every single subnet that we had. And that would be a lot of DHCP services to configure and a lot of DHCP servers to buy. So what we can do is set up a centralized DHCP server. Let's say we attach it right here. It's a Windows box. Or we could make it, you know what? Why would we use a Windows box for DHCP knowing what we know? It's this router right here that is going to be our DHCP server. And it happens to have the IP address 10.1.1.50, we'll say. Okay. Well, what we can do with the IP helper address is go to the places where we will be receiving DHCP requests. Let's start over here with the branch office because that one would be easiest. I would go under this interface, we'll say it's Ethernet 0, and I would type in the command IP helper dash address. I'll just put ADD, and then the IP address that I want to send the DHCP request to, 10.1.1.50. Okay. Now, immediately when it receives a broadcast from some DHCP client, it will convert that DHCP broadcast to a unicast message that goes directly to that interface of the router and says, I need an IP address. Now, you might be wondering, well, with all these different subnets, maybe up here is the 10.3 subnet, and maybe VLAN 300 is the 10.4 subnet, and all of that. How does the DHCP server know what pool to give the IP address from? Well, that's because whatever interface you configure the IP helper address on will be the source IP address. So for instance, if this was the 10.3 subnet, it would come from the source address. We'll say it's 10.3.0.1, which is the internal interface of this router over here. So the router gets it from that source saying, I need an IP address, and looks for something from the 10.3 subnet. Same thing here on this 6500 switch. We probably have multi-layer, what am I talking about? Multi-layer switching services, or layer 3 switching services, where we have VLAN interfaces. Interface VLAN 100, we would put a helper address pointing here. Interface VLAN 200, we would point a helper address that points over here. Let me just show you the command while I've got you here. I can go into interface Ethernet 0/0. This is what the command looks like. IP helper address, and you just type in the IP address that you want to send your broadcast messages to in unicast format. Now, when you use that command, it sends DHCP requests along with many other UDP requests at the same time. This is the list of 8 port numbers that the helper address will send by default. It sends, for instance, NTP time requests, TACAC servers, DNS server requests. In all of these are UDP-based broadcasts. If you want to restrict it to where it only sends, for instance, DHCP client requests, then what you can do is you can go into global config mode and use the forward protocol command. You can see we can type in, yeah, and when I say forward protocol, I mean IP forward protocol. Yes, sorry, I was missing the IP. You can see IP forward protocol, and then I can type in UDP. Now I'm getting these dots of it trying to write bindings to this TFTP server. That's going to be annoying. But you can see UDP space question mark, and there it's saying, what port numbers do you want to send over? And I can type in whatever port numbers I want to. Now I mentioned that it sends 8 different port numbers over by default, and maybe we wanted to restrict it down. Well, in that case, I just would go no IP forward protocol UDP, maybe 37, to now stop the sending of the time request. I would say no forward protocol UDP 137 to maybe stop the NetBIOS traffic from coming across that. So I can actually pull those out, and that's a global command. So that affects wherever you have the helper address on your Cisco devices. So that's what the helper address does, is forward broadcast in unicast format to whatever server you want. Now, the last question that people usually ask on this is they say, well, Can you have multiple helper addresses? I mean, what if you have a backup DHCP server to this one? Or maybe you have different DHCP servers you want to send it to. Yes, you can have multiple helper address commands typed in under an interface, but for every broadcast, it will send a unicast message to every helper address you have. Without getting fancy with route maps, there's really no way to stop that. So whichever server responds fastest is the server that's going to win, essentially. That'll be the one that the client gets the address from, if we're talking about DHCP. And that is our bonus video. I know it was a fast and furious flyby of DHCP services, but like I mentioned, they really do belong in a CCNA level class. That's just the basics of configuring a network. So at this point, you should be able to configure an iOS-based DHCP server just using the IP DHCP pool command. You can use that import all to reuse or import and reuse DHCP options that our router may have got from maybe an internet service provider, like a DSL or cable modem connection. And then the biggest command of all, we just talked about the IP helper address to forward your broadcast, your DHCP request, to a centralized DHCP server. I hope this has been informative for you, and I'd like to thank you for viewing.